Okay, welcome back. And so today we're going to talk about quadratic models, and we're going to do an example. Okay, and so in a lot of quadratic models, it uses the characteristics that we've been talking about here and that I'm going to go over. And so we're going to use quadratic models, meaning we're going to use situations that come up that follow a parabolic shape. And there's certain circumstances that come up where we are going to want to use a quadratic function to model the data, to model the information that we're given. Okay, so for example, if we have a projectile, a ball, an arrow, a rock that's thrown upward or thrown at an angle from the ground, those sorts of things are going to follow, as we know from physics, follow a parabolic shape. And so it's going to have, in fact, this is one of the equations that we use, or one of the models for modeling the trajectory of an object. Okay, so S of t is the position of the object after time t. This negative 16 is based on the acceleration of gravity, okay, in meters per second. I believe this is in meters, based on meters per second. No, this is in feet per second, sorry. Feet per second squared. Okay, but again, you don't need to know that, but it's negative 16. Plus, then the v naught, or v sub 0, is the initial velocity. This is initial velocity. And this constant is the initial position. Okay, so if we know the initial velocity and we know the initial position of the object, then we can solve to find out, hey, where is this object, or what is the height of the object after so many seconds, for example. Okay, so before we get into that, a couple things. We know that if A is negative, then we know that the parabola, the shape of this thing, opens down, and we know that the vertex is going to be a maximum point. So sometimes we want to know, hey, where's the maximum height, or what's the minimum cost, or something, you know, if we're looking at a parabola that opens upward. And so in those cases, we would have what? A positive A. If A is positive, we know the parabola opens upward, and our vertex is going to be the minimum point. And if it's negative, it's going to be opening down, and we have a maximum point at the vertex. And so in circumstances or situations or applications, we want to know, where is that maximum or where is that minimum? Okay? And then also we want to know, hey, where does that maximum or minimum occur? So that means we want to find the x value that corresponds to the y value. So in other words, we want to find the vertex of the graph of the parabola. Okay, so let's use an example. So let's say we're given this example, and we're going to use this function here, this model, and this model is used to track or to represent or model the trajectory of an object that is thrown up into the air. Okay, and so let's say in this example, a ball, where we throw a ball directly upward. And from an initial height of 100 feet, so that's our S sub 0, with an initial velocity of 80 feet per second, that's going to be our V sub 0. So the first thing is we want to be able to write this function with all the pieces put together. And so that's part A. So part A says, hey, give the function that describes the height of the ball in terms of t. So in this case, t seconds. Well, all we're going to do is we're going to take this function here and we're going to plug in the values that they give us. So for part A, we're going to say S of t is equal to negative 16 t squared. V naught is 80. So plus 80 t, and then the initial height is 100 feet, so we're going to plus 100. Okay, and that's it. Okay, so then part B says, after how many seconds does the ball reach its maximum height? Okay, after how many seconds does the ball reach its maximum height? And what is the maximum height? Okay, so that means they want us to find the vertex, in other words, right? So if you find the vertex of this, the graph of this equation here, this function, then we will be able to answer both of those questions. Okay, so how do we do that? Well, let's use the vertex formula. So in this case here, t is in place of x. So our vertex formula is going to be t equals negative b over 2a. Well, now we just need to plug in b and a, right? Well, a is negative 16, right? So let's plug in 2 times negative 16. And then b is 80, so we're going to put negative 80 here. Okay? Why? Because we have a negative sign here. And so now we're going to simplify this. So this gives us what? Well, when we simplify this, this is going to give us, well, a negative divided by a negative is positive, so those are going to cancel each other out. 80 divided by 2 is 40, so we're going to get 40 over 16, which are both divisible by 4. So we're going to get 10 over 4, which gives us what? 5 halves. Okay? So there's our t. Okay? So the ball reaches its maximum height after what? 2.5 seconds. Okay? Okay. So what is the maximum height? Well, now we're just going to plug in 2.5 into here. Okay? So let's do it this way. So we're going to do f of 5 halves, which is going to be equal to negative 16 times 5 halves squared plus 80 times 5 halves plus 100. Right? And so what do we get? We get, well, negative 16, so this is going to be what? Negative 8 times, or this is 25 over 4. Okay, so this is going to give us what? This is 25 over 4, so 5 halves squared is 25 over 4. And so this is going to give us what? Negative 4 times 25, and which is going to give us negative 100. So negative 100 plus what? Well, this is 40 times 5, which is what? 200. Right? So 40 times 5 is 200 plus the 100. Well, guess what? That means those are going to cancel out, and guess what? The maximum height that the ball travels, or reaches rather, is 100 feet. So there it is. That's part B. So the time after we throw the ball up that it reaches the maximum height is 2.5 seconds, and the maximum height is 200 feet. And that's the answer for part B. Okay. So, now to part C. So what do they say in part C? Well, in part C they say, hey, for what interval of time is the height of the ball greater than 160 feet? Ooh, this is a good one. Okay, so C, we want to know, hey, for what interval, time interval, is the ball greater than 160 feet? So, in other words, think about it. You throw the ball up, and as it's going up, it's going to reach and pass 160 feet, right? And it's going to keep going up. And then it's going to stop because gravity, and it's going to bring it back down, and it's going to come back, and eventually it's going to reach 160 feet, and then it's going to drop below that. So there's going to be a time interval where it's going to be above that 160 foot mark. Okay? So now, so how do we set this up? Well, let's use the equation, right? So we want to set this up where we have negative 16t squared, right, plus 80, oops, not 80 feet, 80t plus 100 is greater than, right? So we want to know, when is the graph of this thing, when is this graph greater than 160? Okay, now, here's what I'm going to do. I'm going to change this. Well, actually, you know what? I'm going to leave it alone. I'm going to leave it alone. I'm going to leave it alone. So now I'm going to solve this inequality just the same way I would solve a quadratic equation. So I'm going to move the 160 over here. So I'm going to rewrite this. So I'm going to subtract 160 from both sides. So now my formula is going to be negative 16t plus 80t minus 60, which is greater than or equal to 0. Now, if you, again, pause the video and do this yourself. Don't just watch the video and say, and then look at the video and say, oh, I don't know where you got that. You know, do the process, subtract 160 from both sides, and do this. Okay? So again, just pause the video if you get stuck. Just make sure you know how to go from here to here. Okay, now, what am I going to do? Well, what I'm going to do is I'm going to see if I can factor, right? Because I want to simplify this and then basically divide by the largest number, right? The greatest common factor. I'm going to divide both sides by the greatest common factor because I can always divide this by a non-negative and it's going to be 0. So, and then it'll simplify this side. Okay, so what can I do? This and this, I believe it's all divisible by 16. Let's see. Yes, I believe it's all divisible by 16. Yeah, I think so. I think it is. So this, what I'm going to do is I'm going to divide by negative 16, okay, to make this positive. So I'm going to get t squared minus, and how many times does 16 go into 80? Well, it's going to be, I believe, five times. 5 times 16 is 80. This is going to become plus. Okay, how many times does 16 go into 60? Nope, it doesn't work. That's 64. I thought I was going to get onto something. That's not going to work. Okay, so but we can still factor out. We can still factor out a 4, right? So negative 4. So let's do negative 4. So this is going to become negative. This is going to become 4, right? 4t squared minus 20t plus. And this will be 15. Okay. And so now here's the trick. Be careful. Since I'm dividing by -4 on both sides, this is now going to become less than or equal to 0. Remember, when you're dealing with inequalities, if you multiply or divide both sides of the inequality by a negative number, you must flip the inequality. So that's what I did. Okay. Now, so here's the thing. Now, is this factorable? Okay, well, we get 60. Are there two numbers, right? Two numbers that are positive or both negative that will give us a -20. So they have to be both negative. So we have 4 times, so we're going to use the AC method. So we get 4 times 15, which is 60. So two negative numbers that are factors of 60 that will add up to -20. Okay, and are there two numbers? Okay, well, so 60. So are there two factors of 60 that will add to -20? Well, you could do 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and what? 5 and 12, right? Doesn't look like it's going to happen. So, and then 6 and 10, yeah. Yeah, it looks like we're not going to be able to find factors. Yeah, that's it. Nope. It looks like we're not going to do it. So guess what? But that's okay, because now we can use the quadratic formula. Okay? So let's use the quadratic formula. So let's find t. Okay? T is equal to what? Well, a is 4. So it's going to be negative b plus or minus the square root of b squared minus 4ac over 2a. Okay? So now we know a is equal to 4, b is equal to -20, and c is equal to 15. So now all we have to do is substitute or plug in. So negative b, so this is going to be 20. So negative of a -20 is positive 20. So it's going to be positive 20 plus or minus the square root of -20 squared minus 4 times a, which is 4, times c, which is 15, over 2 times 4. Okay, now, what do we get? We get 20 plus or minus, what do we get? We get 400 minus what? Well, this is going to be 60, so 4 times 60 is 240. Over 8. And so when we simplify this, what do we get? We get, well, 160. And so when we do the 160, we get what? We get 20 plus or minus, well, this is going to be, this is going to be 4 times 10. So 4 times 10 would give us 2 times the square root of 10 over 8. Okay? Now, if we stick this in our calculator, we can come up with a couple of answers. So again, since this is an application type problem, this is where we just use our calculator. And so what I'm going to do is I'm just going to calculate, hey, what is the two time periods? So I'm going to do 20 plus 2 times the square root of 10 divided by 8. And I get 3.29 seconds. Okay? So I get t equals 3.29, is that right? 3.29 seconds. Okay? Now let's do the other one, because now we have to do the subtraction. So let's do 20 minus 2 times the square root of 10 divided by 8, and we get 1.71. 1.71 seconds. Okay, so guess what? The answer to the question is, what is the time interval that the ball is greater than or equal to? Is it greater than or greater than or equal to? I just want to make sure. Greater than. Okay? Greater than. So we didn't need this. So it's greater than. Okay? So the answer is, well, the ball is greater than 160 feet from 1.71 seconds. So again, we can write this as an interval. So from 1.71 seconds to 3.29 seconds, and we're done. And that's the answer. That is the time interval when the ball is above 160 feet. Okay, now, D. After how many seconds will the ball hit the ground? Okay, so for this one here, they're asking, okay, when will the ball hit the ground? Okay, well, when the ball hits the ground, what's the height of the ball from the ground? 0. So we're going to do the same thing, except now what we're going to do is we're going to solve for f of x equal to 0. So this is going to be negative 16t squared plus 80t plus 100 equal to 0. We want to know, when is the height of the ball 0? Right? Because that's when it hits the ground. So let's solve this. Okay? Now again, here we're going to have to factor out, we can divide by a negative, here we can't divide by negative 4, so let's just simplify by dividing by a negative 2. Right? So if we divide by a negative 2, we get 8t squared plus, or excuse me, minus 40t minus 50 equals 0. Now, again, this is not going to be factorable. Okay? So let's just use the quadratic formula. Okay? So let's find t is equal to negative b. Well, that's going to be negative of a negative 40, so that's going to be 40 plus or minus the square root of what? B squared, which is negative 40 squared, minus 4 times a, which is 8, times c, which is negative 50, over 2 times a, which is 8. Okay? So now let's simplify this. So again, we get 40, let's see, 40 plus or minus. This is going to be what? What do we get inside? So let's just grab the calculator. And so we're going to get 1600, right? So 1600. And then we got a minus times a minus, which is going to give us plus. So plus 4 times 8 times 50. And so we get 3200. Okay, so this is going to be the square root of 3200. And we're dividing by 16. So now let's find out what our two values are for t. Okay, so let's do subtraction first. So we're going to do 40 minus the square root of 3200 divided by 16. And we get negative 1.04 seconds. So we get negative 1.04 seconds. And now let's do plus. So we'll do 40 plus the square root of 3200 divided by 16. And we get 6.04. Okay, so now the question is when does the ball hit the ground? Well, we should automatically say that this cannot be applicable, right? Because we can't have negative time, okay? And it should also make sense because when we started throwing the ball, it was already at an initial height of 100 feet, okay? So the only time it would hit the ground is after we threw the ball, which would be when it started at 0, okay? But again, very simple, can't have negative time. So our answer is this one. So the ball hit the ground 6.04 seconds after it was thrown. And that's it. Thank you. Have a great day.